After talking about the impacts of 3D printing, let's move on to some challenges faced by it, with the selection of raw materials being the first one. In order to produce organs that can be used for transplant, it is crucial to select raw materials that will not produce a toxic or immunological response when exposed to the bodily fluids. Otherwise, it will lead to rejections. For example, the use of some polymers that are hard to sterilize will most likely lead to infection after transplant or even multiple organ failure. The second challenge will be the technique involved. A common challenge shared by all tissue engineers is what is known as vascularization. It isn't too challenging to produce the framework of the organ. However, when it comes to creating the intricate networks of tiny blood vessels that carry nutrients and oxygen deep into organs and carrying waste products out, it's not that easy. Hiring scientists that are capable of performing this technique or provide them with training are expected to cost a lot. So, what are some future developments that can help solving the above-mentioned challenges? Machine learning will be the first one. With the advancements in AI technology, combination of machine learning-based techniques and 3D printing can greatly reduce the time and effort required to create highly intricate models, such as organs from imaging data. Moreover, with the use of AI technology, it will increase the quality of the organs produced, such as a more precise resemblance of the blood vessels network inside. The second one will be drug development. A concept of polypill, that is a 3D printed pill housing multiple drugs at once, each with different release time, is introduced in recent years. It has recently been tested for patients with diabetics. It is anticipated that in the future, polypill can be applied to other diseases, which may alleviate the burden of patients financially and physically by reducing the number of drugs they have to buy, as well as the frequency of taking drugs.